Let's see. All right, we're recording now. So problems. Let's look at I don't know. Problem number 1. They tell you you have f at x is equal to 6x, and then they tell you that f at x is equal to negative 24. Okay. So the only way to do this problem is you have the function at x and the function at x. It's the same function. So this will tell you that this will equal this. So you find that x is equal to negative 4. Done.
Oh, easy. I thought I did wrong. Oh, did I do that?
Okay. And then like number 4, they tell you that h at x is equal to 14 minus 8x. And they tell you that h at x is equal to negative 2. So again, you have the exact same h at x. So this is going to be equal to this. And then solve it. So subtract 14 from both sides. And then divide both sides by negative 8. That's all you had to do. So they looked a lot harder than they were, but it's just recognizing how the functional notation works out. Yay? Were you able to find that? Were you able to find the test?
Yeah.
Cool. Oh, and then one thing that you need to know on the test. If you're going to have an answer of like negative 8 to infinity, you would write this as negative 8 comma INF for infinity. Don't write out the word infinity. Or if it was like negative infinity to 7 square bracket, you'd write this as negative INF comma 7 square bracket. Okay? That'll make sense once you get on there because there's not an infinity key. All right. What else did you come across on the homework that was goofy? Yeah. Number 7. Okay. Number 7. Too much chatter going on.
Mr. King, show me the number 5 and 6 too.
Yeah. Yeah, definitely. Those are good ones. Okay. Let's see. You got 1, 2, 3 up here. Then 6, right? All right. So they tell us that this is the graph. F at x is equal to 3 minus 1/2 x. And then use the following. For what values of x is, so letter A, is y greater than 4? Y greater than 4. Okay? So you need to be counting up here. So like here's 4 right up here. And then you kind of extrapolate over. And I think you have a little bit more room on your paper. But if you come up here to 4, okay, because that's a y value, kind of extrapolate over. And if you find that point, it's from negative 2 going back this way to negative infinity. So from negative infinity to negative 2, rounded bracket is where our y component is bigger than 4. Okay, it's continuing up. Then letter B, for what value of x is y less than 0? Okay, so a y value being 0 starts here, okay, because this is the line, this is the x-axis, right? So this goes 0, 1, 2, 3, 4, negative 1, negative 2, negative 3 in the y direction. So what values, so it's all over this way. So we're talking about this part of the line. So again, we're representing it with x. So 1, 2, 3, 4, 5, there's a 6 there. So from 6 to infinity, our graph is now less than 0. Okay, our y component. They become negative numbers. Okay, it's rounded bracket because actually, this is a square bracket. Why is this one a square bracket? Why was this a square bracket here and this was a rounded bracket here? What's the key? Yeah. Yeah, you have this equal to sign, so it means you have to include this point. It keeps going, so you're talking about in the x direction. Okay, and then this one, you had an open dot, basically, so it's a rounded bracket. So at 4, so in the x direction, you go from negative infinity to -2. You continue to have values that are bigger than 4. And then letter C, what are the values of x if y is between 1 and 4, excuse me. Letter C, what are the values of x if y is between 1 and 4? Okay, so what are the values of x if we are going between 1 and 4 in the y direction? So in the y direction, we're right here, going between 1 and 4, correct? So what values of x exist there? Well, if you look on your graph for what this point was, that goes from -2, okay, when it's 4, then you come down here at 1, and you cross on over, and that looks like it is 1, 4. That's what the answer for letter C is. Again, that's not a point, that's in interval notation. And then, what is the domain of the whole graph? Will it go forever to the left and forever to the right where a graph exists above, below, or on the x-axis? So this is continuing to go to infinity in the y direction. Does it continue to go to negative infinity on the x direction? The answer is yes. This is going to negative infinity in the y direction. Does it continue to go to infinity in the x direction? The answer is yes. So our domain is negative to positive infinity. Okay? And then you wanted to go over 5 and 6. Is that what you asked?
Yeah.
Okay. Yep. All right, so problem number 5. We have the function at x is equal to 7. So what value yields that? So you're going to go up to 7 on the y direction, and this would have been the function at 3 would have had to have equal to give me that. So that would yield me the point 3, 7. That's a point, not interval notation. Okay, how did I get that? I knew in the y direction I wanted to get to 7, so I counted up 7, and then I went over to the right. So I went 1, 2, 3 over if you're looking at your paper on number 5. And so that would have been 3 over. So function at 3 is equal to 7, which yields you the point 3, 7. Excuse me. Number 6, again, they want to know, you have the function at x is equal to 7, so it's basically saying the function at what gives me 7. Hey, thank you.
Super.
Okay. So again, we're going to look at our graph at number 6, the picture that you have, and we'll go up to 7, and then we come over to the right. It goes 1, 2, 3. Looks like it's 4 over. So that's the function at 4 gives me 7, which then yields me the point this. So I guess what the answer is, you're finding this right here. And you use it by looking at the graph. In this case, you're doing the function at 7. Function at x equals 7. So you're like, okay, what's my output? What's my range? What's my y component? I think we're good on the front side. Yeah.
Even on the back.
On the back side. 8 and 9. Yeah, let's take a look. All right. Number 8. So you have some graph that does this, right? I might not be exact, but that's for the most part what we have, right? So they ask us for each function, determine each function at x, state the domain and range, state the x interval for which the function is positive, and the x interval for which the function is increasing. Okay. I don't have all of the points labeled here, so I mean, I guess this starts out at like something like this. Is that what it does? And that's -1. And that's, there's like a 2 right there. And that's a +1 up here. And that's 4. And you got 5. And 6. All right. So, I don't see arrows at each side. And I don't see open dots, so I think that we have a dot here that we're not seeing and a dot here. So that means that my domain is going to go from 0 to 6. Okay, and the reason I'm saying that is I don't see arrows that are pointing out. So I feel that this graph starts and stops for whatever reason. Okay, then our range, what's the lowest y value you have? -1.
Oh, yeah, you're right.
Is it?
Yeah.
And then my highest y value is 1. Okay, and again, there's square brackets because it looks like we have points up there and there. All right. The intervals for where the graph is increasing. Okay, this is the newer concept, so let's talk about this.
So we have to choose 2 for domain stuff.
Yeah. Because the domain went from right here to right here, and then range went from the lowest y to the highest y. All right, so where it's increasing is here and here. Those are the only 2 spots that this graph is increasing. I guess there's 3 right there. Okay, and the reason that we say that, again, I can't emphasize this enough. This is a big concept that a lot of students in Algebra 1 are just like, don't get it, okay? If I were to pick any 2 points along this line here or any 2 points along this line right here and I were to find the slope, it doesn't matter if that's a curved area or not, but if you pick 2 of the points on those 2 blue regions, being that they're both growing towards the upper right-hand portion of the graph, if I were to find the slope using my slope equation, which is m equals y2 minus y1 over x2 minus x1, and again, I'm going over that quick, so we're going to hit that a little bit more. But if I were to pick any 2 points on those blue lines, same blue line, don't be like this blue and that blue. No, it's pick 2 points, here and here, or real close together, or here and here, or far away on those lines, and I would have a slope that would be positive. Okay, so it's increasing from 1 to 2 in the x direction, and then it's also increasing from 3 to 4. Okay, so my graph is off a little bit. This one should be shifted over. I apologize. My freehand drawing isn't as beautiful as the thing on there. So that are these points right here. Are those points? No. It is not the point 1, 2. That is interval notation. So it says from the number 1 to the number 2, if I go right here, I have a line that would be increasing. And then from the number 3 to the number 4, I have a line that's increasing. Okay, my graph increases. Again, increasing means you'd have a positive slope. And then where is the graph positive? Okay, positive is anything above our line. So in that yellow region, that's all positive. It's above the x-axis, okay? Okay, so where is it positive? So I'm starting from, where does it appear that it goes? This is the point right here, like 1.5. And this is the point here, 4.5. So we're telling the story in the x direction. So from 1.5 to 4.5 in the x direction, our graph exists above the x-axis, therefore it's positive. Is that 1.5 comma 4.5, is it a point or is it interval notation? It's interval notation. You're telling the story between these 2 regions, from here to here, I happen to get this graph that's existing in a positive location. That's a big idea. Holy cow. And then number 9 is going to be done very similar, so I think you'd be able to do number 9 with the knowledge of this one. Is there any questions on 10 through 19?
Can you go over 10, please?
10, yeah. Problem number 10, we have the function at 3. That's a bad 3, but we'll call it okay. And we're going to use f at x graph. The reason we're using f at x is because we're saying f. Okay, so the function at 3 is equal to 2 parentheses. There was an x there, but now I'm going to put the number 3. And that would give me 6 minus 3, which in this case is 3. Any other questions up through number 19? 12? 12. You have g at 0. So you're going to use g at x equation. So g at 0 means I'm going to plug 0 squared plus 1. So that's 0 plus 1, which is 1. And then what else? Anything else on up through 19? Going once, going twice? So, okay. So, guys and girls, before anything comes forward, look at, if you're giving me one sheet or multiple sheets, take a look at each of the sheets coming up. Make sure you have a name on there. Yesterday, and not this, maybe in this class, I don't know, there might have been a no-namer, but it seemed like yesterday I had kind of a significant amount of no-namers. Included in an email from a parent going, my kid said they turned it in. They might have, but they might have gone with the mystery name. I think all of these have names on them. You good? Yeah.
Don't rush me.
All right. That is a funny old video. All right. Coming back out to you all is last time's homework, and as I flip through, it looks like everyone has their names on it, so make sure you grab yours and pass on the rest. Okay. I would like to finish up going over this sheet. So if you have this, I just want to talk about it real quick. I want to finish up going, this is what we were doing yesterday. And we had already done the front page of it. So I want to just move on to the back page and make sure that we feel comfortable with the back page. And I apologize, that's blurry. I'm not sure why.
The packing you did?
Yeah. Oh, thank you.
Oh.
All right. So, taking a look at this particular graph. Okay, I tried to draw it as best I could, but with a limited amount of time, I couldn't get it exact. So, from here to here, and from here to here, my graph is increasing. So tell me in your words, what does it mean if it's increasing? Oh, but what does that mean? Better than going up, because it's going up in both directions. It would be a positive slope. So anywhere on those two pink lines, if I pick 2 points on the first pink line or 2 pink points on the second pink part of the line, that would tell us that we would have a positive slope when we use the slope equation. Okay? So where is this graph increasing? So this, remember we tell the story in the x direction. So going out this way, it's still continue to go this way. So from negative infinity all the way into, it looks like on our thing, like negative 1.9. Okay? That's increasing. And then it's increasing here as well, so starting about that point. So that's at about 1.9. And this is going out to infinity. So again, you're telling the story in the x direction of what the graph would be doing. So between those regions, you have an increasing slope. Okay? Where is the graph decreasing? So from here to here, we have decreasing. Okay? So that means the slope would be what?
Negative.
Negative. So from 1.9, negative 1.9 to positive 1.9. So from here in the x direction to here in the x direction, this would, between these 2 points, if I come up to my x components, you have a decreasing slope. And then they want you to find f at 3. So you go over to 3, it looks like f at 3 is 0. F at 0 is also 0. F at negative 2 appears to be at 10. Agreed?
Agreed.
The domain, this graph goes forever left and right, so the domain goes from negative to positive infinity. My range, even though we have a little change or a wiggle that takes place right here, it still continues there, so my range has to be positive or negative to positive infinity as well. And then, where is it positive? And it's positive here. Anything above here, that's all positive region. Okay, so we have this huge amount of yellow, so we have to talk about, again, using the x to tell the story. Where is this? No, it has to be a back color, right? Yeah.
So the domain and range are what again?
Domain and range are both negative to positive infinity because it's continuously going to the left, continuously going to the right, it's continuously going down, it's continuously going up. Even though there's a wiggle in there. You see the wiggle? It's where it changes directions a couple times. All right. So where is it positive? Anywhere, again, we're using the story. We're using the x to tell the story. So it is positive from negative 3 to 0. Is that a point or is that an interval notation? It's a point. And then where does it go back to being positive again? So from 3 now to infinity. So as soon as I come above this line, from negative 3 to 0, this whole region's positive as far as our graph goes. And then it goes down and becomes negative down here, but it just does change direction, comes up. As soon as it gets here to 3, it comes back up, and it forever this way. Again, you're using the x to tell the story with what the graph is doing. Okay? So, look at the grid now. We have A, B, C, D. I'd say A is a function, B is a function, C is not, and D is not. Why is C not a function?
Because the domain repeats.
The domain repeats. Why is D not a function? Because that's all the domain does is repeat. It's going 2, 2, 2, 2, 2. Okay, letter E. My domain would be on the left side is 1, 2, 3, 4. And 1, 2, 3, 4 goes to, you're not using 1, 2, 3, 4 on the left twice. So that is a function. And then if you look at letter F, you have M going to a frowny face. Then you have T, S, and F. And they are all going to smiley face. So is M, T, S, or F being used more than once?
No.
No. The Y happens to repeat with a smiley face or a frowny face. And then if we look at letter G, it looks like 4 goes to 10, 5 goes to negative 2. We don't use the 9, it doesn't go anywhere. 8 goes to 10, and 8 goes to 5. So is the left side, the X, the input, being used twice? Yeah, 8's being repeated, so G is not a function. Letter H is also not a function because you'd have 1, 2 and 1, 4. You'd also have 5, 6 and 5, 8. So H is not a function. If you look at I, you're looking at your x values. You have 4, 2, 1, 10, and 0. They don't repeat. You have a function. You look at J, your x values are 2, 2, 2, 2, and 2. That sounds like they're repeating. So our domain repeats, so letter J is not a function. Letter K, our x values are 6, 6, 6, 5, 5. So the 6s are repeating as well as the 5s are repeating. So that's our domain's repeating, so it's not a function on K. Letter L, we have -2 and we have 3 as our x values. They don't repeat, so it's a function. Letter M is a function. I could do the vertical line test and it would not cross it more than once. Letter N, function or not?
No.
Why not?
Because it wouldn't pass the vertical.
Yeah, the vertical line test, you draw a vertical line, heck, you can see the y-axis crosses it 1, 2, 3, 4 times, so right there, it's not going to work. Letter O, it looks like you have a W in there, kind of. Does that pass the vertical line test?
Yeah.
I think so. That's a function. Letter P, trick question. Letter P, it's a vertical line. Does a vertical line pass the vertical line test?
No.
Yeah. No, it's not a function. So vertical lines aren't functions. Letter Q, I will tell you that's a linear equation that has a y-intercept of 3 and a slope of 2. That's definitely a function. Letter R, definitely a function. And then S and T, you guys can do that on your own. I don't need to go to that. So that's kind of that. We'll function.
You said Q was not. I mean, what? Oh, I forgot what I said.
Q was? Okay. Q was a function. Don't be afraid. I think today might be a calming kind of day where we can kind of backfill a whole lot of different ideas. 3. Damn it. 2. And 3. I forgot to take you guys up. All right, everyone got a homework or a note sheet? Here we go.
Are these going to be turned in at any point?
Those no, they're just kind of like a supplement to notes.
Okay.
All right, so we are continuing our graphing of linear functions. Linear functions is a straight line. It's a straight line. Linear functions don't have any wiggles. Wiggles are where they change directions. All right, so here we go on the notes. So number 2. So linear function, things that you should know. You have x and you have y. X and y are not raised to exponents. Okay, that's for the most part. So we'll get to more. All right, so problem number 1. Does that appear to be a straight line linear function? No. It's a parabola. Problem number 2. Does that appear to be a straight line linear equation? Yes. Everyone still with me on this adventure?
How was number 1?
Because it's a parabola, it changes directions.
Oh,
Okay? So where it changes directions there at 0, 0, it's kind of a wiggle, they call it. Okay? All right, problem number 3, 0246 is our domain 392781. So what I would do on this one is I'd go 0, 3, 2, 9. That definitely could be linear. And then 427, way up there. This is actually curved. Does that look like to be a linear function? I will tell you the rest of this function, if you continued it, it's going to do this. Linear or not? No. Curved lines aren't linear.
So it's just a straight line.
Why can't the words be straight?
Huh?
Why can't the words be straight? Linear?
Linear, straight. Okay. Yeah.
Wouldn't it be easier to say x and y, they are in an ordered pair, so say every single time blank goes into blankets times 2 or plus 2, whatever.
Oh, you saw something there, Jasper. Nice. I like what you're thinking. You're absolutely right. So, you absolutely. And I was just trying to show you the simpler or quickest way, but you see your way. Please keep doing it. You're seeing it. That's huge. You just made a leap. I love it. All right. Does 1424, 2420, 3416, 4412 form a straight line?
Yes.
So each of these jump up by 10, right? Those all jump up by 10. Is that okay? The nice thing is there's a pattern to it. What about this way? I subtract 4, subtract 4, subtract 4. Okay? Do you think if I add 10 each time for my x's, sorry if I'm interrupting your conversation, or each time I subtract 4 from your y's, do you think that would form linear? Is it kind of consistent? Does it keep going and going? Thank you. What do you think? Linear? Absolutely. So this one is definitely linear because I go up by 10 each time or I subtract 4 each time. So that's definitely a linear situation.
If there's a pattern going on, then it's linear.
A pattern like as simple as that, yes.
Okay.
I wouldn't do a pattern if it was like the y's were going from 1 to 8 to 64 to 125, things like that. All right. So problem number 5. Shh. If I were to add 1/3 x over to here, do I still keep my value being x somehow, even though it's a fraction?
Yes.
Yeah. So in order for it to be linear, your x and y values need to be just simple x or y values. They can have a number next to them like you're multiplying. They can have a number underneath them like you're dividing. But x and y can't be dividing each other. You can't have x over y or y over x. But if you have x and y being added together and x and y are only raised to the first power, so you don't have y to the third and x to the seventh. So this is linear. So with what I just said, does that make sense for number 6 to stay linear?
Can you make it more simple?
You could try and solve it for y, but you could look at it too going, okay, if I were to add 2 over 5x to the other side, I get 6 equals 3y equals 8 2/5 x. And that's pretty simple, so that works. Yeah.
For that one, would you go down -1 and over 3 positive or over left negative?
Well, it's not completely solved, so let's not. You'd be right if we just had a negative 1/3 x, and that was the only thing. We'd be down and right, but where we have another x value to contend with. Yeah.
So would you look at the last part? So for example, 4x minus 7 to find out if it is different.
You could. So if I were to add 1/3 x to the other side, you get y equals 4 1/3 x minus 7. That's a linear equation. Okay? 7. If I were to start foiling this out, I'd wind up with y squared plus 2y minus 4y minus 8 equals 3x. So is that linear or not? No, it's not, because you have a what squared value? The y squared. So this is not linear. This one, x and y are being multiplied together. It is not a linear. It doesn't form a straight line. It does form a graph, but it doesn't form a straight line when you graph it. All right. So discrete starts and stops. Continuous, negative to positive infinity, goes forever. Okay, so what is the independent variable? What is the dependent variable? Determine if the domain of the function is discrete or continuous. Okay, the cost to enter a haunted house depends on how many people are in your group. Cost to enter a haunted house depends upon the number of people in your group. So your group is your independent. The cost is your dependent. Okay? Can you have an infinite amount of people?
No.
No, it's impossible. So this has to be discrete. Huh? Yes. That'd be a big haunted house. So this is a discrete situation. The amount of money made at the pumpkin patch depends on the temperature during the day. So temperature is your independent. And again, your money you make is your dependent. Again, can you make infinite money? No. However much money has ever been created is the amount of money we can use. We can't go beyond that. All right, so A, so if you have the function as A, this is your input, B would be your output. So if you use this equation, function at x is equal to negative x plus 5, what do I do with this 0? No. No.
Put in nothing.
Put it in. So this becomes negative 0 plus 5. Negative 0 is 0. 0 plus 5 is? 5. What's the answer here then? 5. Okay? Then I take the negative 1. What should I do with this negative 1? Plug it in. So I get negative 1. What's negative 1? No. 1. 1 plus 5 is? 6. Okay, those are just plug in. But then it changes a smidge. So now we're saying the function at x equals 0. So this says I need to go 0 equals negative x plus 5. Subtract 5 from both sides. Divide by x. This one says, hey, find x if the function x equals 0. Oh, it's the same. It's the same problem. Don't know what they was thinking. Okay? So sometimes you will plug in to the outside. Sometimes you plug in for x. This is my last slide then. Let f at x be the percent on the next math test where x is the number of hours you studied. 4. Explain the meaning of each. So let f of x be the percent. So if you got a 0, that would mean you scored. You didn't study. You got a 0. This means if you study 5 hours or 6 hours, you get the same exact score. So save an hour. This means if you study 2 hours versus 3 hours, you get a lesser score on your math test. All right, so what I'd like you all to work on is page 55 and 56.
The whole page?
Yeah, you should be able. It should be fine. Some of them are just, hey, is this linear or not? Is this discrete or not? Should be able to do them. So, guys and girls, I will tell you a few things I'm starting to notice from some people in some of my classes. Some people from some of my classes are choosing not to have homework done. Often. Not from time to time. I'm not talking if it happens from time to time. There are some people who the last time you handed in an assignment to me would have been never. Your grade looks bad because of it. Oh, I forgot yours. I'm sorry.
Not me, mister.